and welcome to the Children's Museum of Cleveland. I'm Miss Kelsey, and I have another exciting STEM experiment for you today. This is another experiment that you can try at home, but you might need an adult's help. This experiment is going to use something called red cabbage water. So I got some red cabbage, I cut it up, I boiled it, I let it cook for 10 minutes, and when I drained the cabbage, I collected the water for this experiment. So if you want to do this at home, you're going to need an adult friend to make this cabbage water for you. The other things we need are just a few empty jars to pour our cabbage water into, and a couple items to test. I had these items lying around the museum. You might have them at home. I had liquid starch, baking soda, vinegar, and hydrogen peroxide. So today, we're just going to be testing these 4 items, but if you try this at home later, you can test more than 4 or the same 4 that we're doing today. And the test we'll be doing is called a pH test. pH stands for the potential to have hydrogen. What this test tells you is if an object is an acid or a base. Now here at the Children's Museum of Cleveland, we love knowing if things are acids or bases because we use acids and bases in a lot of our science experiments. If you've ever made a volcano using vinegar and baking soda, you are using a reaction that involves an acid and a base. And the byproduct, or what that reaction creates, is water and an ion solution. And that's how you get your erupting volcano. So we want to know more about acids and bases so we can try more experiments on a different day. So for this test, our acids are going to release a proton ion. Now that's a fancy way to say an acid will show a hydrogen. And acids are going to show up as a red, a pink, or a purple color. The more acidic it is, the brighter the color. Now our bases are going to accept a proton, which is a fancy way of saying it's going to make hydroxide. And our bases we expect to be more of a blue or a green. So our acids will be a bright color. Our bases will be a blue or darker green. So before we begin this experiment, like any good scientist, we need a hypothesis, or we need to make some guesses of whether these 4 items are going to be acids or bases. Our first item is vinegar. And let me give you a clue. An item that is acidic will often taste sour, like a lemon, and something that's a base will taste bitter, like coffee or an orange peel. So our hypothesis for vinegar. Well, I think vinegar tastes kind of sour, so I'm going to say my vinegar is going to be an acid. So I'm going to put in A for acid. Now my baking soda is kind of a bitter tasting item, so I think it's going to be a base. So I'm going to put a B for base. Now hydrogen peroxide and liquid starch are a bit newer to me. So I'm just going to do my best guess. In hydrogen peroxide, I see that word oxide, which reminds me of the hydroxide released by a base. So I'm going to guess that maybe it will be a base. And my liquid starch, just to make it even, I'm going to guess it's going to be an acid. Now my hypothesis might be wrong, it might be correct. Either way, it's just my best guess before I start the experiment. So what I'm going to do now is take my cabbage water, which already has a slight blue shade, meaning my water at home must be a little bit basic. And I'm going to just pour it into the jars. I'm going to try to do it about even, but it doesn't have to be perfect. So I have my 4 jars with some of my cabbage water. And I'm going to add my vinegar first because it's first on our chart. So I've poured some vinegar into this cup. I actually might add a little bit more. And we predicted that the vinegar was an acid. So we should see a pink or purple color. Let's pour it in and find out. So very quickly our vinegar turned bright pink. So our hypothesis was correct. This is an acid. Next we have our baking soda. We predicted our baking soda would be a base. So it might stay a blue color, it might even become a little green. Give it a stir. It has definitely stayed in the dark blues. It has not turned bright pink. So we are correct again. Our hypothesis was that it was a base, and our results are showing the same thing. Next, I'm going to come back over here to get my hydrogen peroxide. Many of you might have this in your medicine cabinet at home. Gonna pour some in. Now we took our best guess and said maybe it's gonna be a base. Let's pour it in and see. Whoa. So this one turned purple. So if we look at our chart, purple is actually an acid, not a base. So our guess was wrong, which is okay, that's how we learn. Hydrogen peroxide is actually an acid. But because it's purple instead of that bright pink, it's less acidic than our vinegar. And our final item is our liquid starch. You might have this at home to help with laundry, or we use it here to make slime. So we predicted our liquid starch was going to be an acid. We'll pour it into our last jar. Give it a stir. It looks like this one also turned purple. So it's right here along that 6 range, and we were correct. It is slightly acidic. So friends, we learned that some of our items, like our vinegar, is an acid. It releases a proton ion. And some of our objects are bases, like our baking soda, that accept a proton to create hydroxide. In a different video you can watch on our website, you can see what happens when we combine baking soda and vinegar and a chemical reaction that results from acids and bases combining. But for now, we'll see you next time, and I hope you enjoyed this pH experiment.
For more programming like this, see cmcleveland.org.